There are probably hundreds of ways to describe colors. And if you go looking around on the web at different websites, and if you look at different programs, you'll see that many of them offer you a variety of color spaces in which to describe your colors. But almost all of them will provide you the RGB system. It's the closest thing we have to a common language for color descriptions across all computer programs. RGB stands for the three primaries of light: red, green, and blue. Now, as we saw when we talked about color systems, if we run white light into a prism, it breaks it up into all the rainbow colors. And if we look at this picture, we can see that the colors that are dominant to our eye are red, green, and blue. Now, this has a lot to do with the physiology of our visual system and how the cones that layer the surface of our retina respond to light. Now, if we look at red, green, and blue and imagine that we're shining red, green, and blue lights onto a card, we can get a diagram like this. Where the red and green light overlap, we get yellow. Where the red and blue lights overlap, we get magenta. Where green and blue overlap, we get cyan. And where all three colors overlap, we get white. The colors are generally becoming lighter because we're adding more light to the mixture. So this is fine. Suppose someone asked you to match a particular color using red, green, and blue. And the question is, how much of each of them would you need to get to a particular color? Well, the way to think about this is to think about the physical space of all the colors that you can create with red, green, and blue, and then find out where you are in that space. That space is called the RGB color cube. Let's take a look at it. So here's the red, green, blue, or RGB color cube. And I'm moving it around with my mouse. You can see I'm kind of tumbling it around a little bit so that you can clearly see that this really is a three-dimensional shape. This is a cube. The corner that's nearest us is black. And that's because this is the corner that represents the color we get when we have no light at all. It's just like being in a dark closet with the lights turned off. You can't see a thing. It's black. The three edges coming out of the black corner show what happens as we add more red, green, and blue light in our dark closet. So let's look at this face where we're adding together red and green light only, and we're keeping the blue light turned off. You can see that as we add together more and more red and green light in equal quantities, we get brighter and brighter yellows, until in the upper right corner we have the brightest yellow. But we also have all the other mixtures of red and green at different intensities. And so in sort of the upper left part of the grid, we have the lime greens. And in kind of the right side of the grid, we have oranges. Let's look at the other two faces that mix the other two primaries. So now we're going to mix green and blue. And as we know, they make cyan. And so that's in one corner, opposite the black corner, but we also get all the other nice mixtures of green and blue across the face. And finally, what if we mix red and blue? Well, we know that they combine to make magenta, but we also get all the other colors, all the purples and dark reds and so forth across the surface of this face. Now let's tumble this back so we're looking at the black corner and remind ourselves that we have red, green, and blue coming out of the black corner. And then the far corners are cyan, magenta, yellow. So what's on the opposite corner from the black? Well, let's tumble this whole thing around. And you can see now these top faces merge secondaries. And the far vertex is white. So tell you what, let's just look at the skeleton of this cube. Here's the near face, which is white. And its three nearest corners are the secondaries: cyan, magenta, yellow. If I tumble this around so we're looking down the black corner, you can see its three nearest corners are the primaries: red, green, and blue. And then the secondaries are out there, and white is all the way at the far end. So if black is at one corner and white is at the other corner, you might guess that the line between them is the grays. And indeed, that's exactly how it works. So any color that's on a line from black to white is a shade of gray. Just as any color on the line from black to pure red is going to be an increasingly brighter red. So let's go back to looking at this cube and tell you what, I'll make the boxes a little bit smaller so that you can kind of see into them. And you can see, yeah, this really is a solid, but it's a little bit hard to picture this, and it's a little hard to see what's inside the solid. So I'm going to do something a little weird, and that's I'm going to show you just a random fraction of the cubes on every frame. And so here they are. They're just jumping around like mad, I know. But I'm going to tumble this around a little bit. And you can see, if you kind of let your eyes defocus and wander over this, all the colors are in there. If you have in mind a particular peach or a crimson or a green, it's in there somewhere. So the question is, how do you find it? Well, that's the job of a color picker. So I'll tell you what, let's look at the RGB cube and see what happens if we start slicing away one face. And I'm just going to sort of chop up from the bottom. So I'm revealing what happens as we go up, and we're slicing off this green face. And you can see the cross section that is revealed. And so we're looking at different slices through the color cube. And I can even make this thinner and I can move it back down. So let's watch it from the top as we move it back down. Well, as I move it back down. And you can see the different colors that we get by slicing through the cube. Well, this is actually a really nice way of looking at the color cube, but it may not be very intuitive. You may not be able to look at this and think to yourself, oh, I know where peach is located, or I know where my favorite aquamarine is located, because it's not the most natural kind of color representation, at least not for me. It certainly works, and I can find colors, and over the years I've become better and better at it. And things like this have been able to help me picture what's inside the color cube. But it's not the most natural thing in the world, and there are alternatives. On the other hand, this is common to almost every computer graphics program. So being comfortable and familiar with the RGB system and being able to imagine, yeah, if I have a particular color and I add some more green to it, it'll do this kind of thing. Or if I add a little bit more yellow, which means both red and green, it'll become a little bit more yellower, is a very useful skill. So by having the primaries and the secondaries and even some of the tertiaries at your fingertips, you're able to maneuver through the RGB space. But again, the whole purpose of using a color picker is that the sliders help you interactively explore this space.